Right, a couple of little helpful hints for Pythagoras' theorem and trigonometry questions. Now, I've drawn two right-angled triangles here, and I just want to show you what it looks like if you put one triangle over the other one. Okay?
The sides with the right angles will hide each other.
So I can do that. I can see there's two right-angled triangles. I can even, if I shrink this one so that it looks like that, I've still got two right-angled triangles. Ignore that bit of line. That shouldn't be. Right, but that diagram there is actually two right-angled triangles, one on top of the other. I have messed it up a bit, but you get the idea. So sometimes a diagram will look like one right-angled triangle and a non-right-angled triangle plonked on top, but actually it's two right-angled triangles, a big one and a smaller one on top, and that's the way to think about it. There is another shape that quite often has right-angled triangles involved.
Square.
What shape is that?
Square.
Stop hacking up. Yes, don't. Just pay full attention.
That's a rectangle.
It's a rectangle. Now, if I take a rectangle
And you split it diagonally.
and, well, I could do that, but I'm not. I'm going to add a right-angled triangle on one side. Okay? What shape do I have?
A trapezium.
A trapezium, yes. Or a trapezium. Or a trapezoid. Or whatever you want to call it. Okay? It's a trapezium. But you notice how I could start with a trapezium. Right? Right. I could start with a trapezium, and I could cut a trapezium into a rectangle and a right-angled triangle, where the distance, okay, the distance of the whole side of a trapezium is actually made up of one side of a right-angled triangle and one side of the rectangle. That's also a normal question. All right? That can be done in any way round. I remember seeing a question once, which was, here is a pillar, here is another pillar or post, and someone has attached a wire across like that because it's a washing line or something. Okay? And they wanted to know how long the washing line was. Okay? Is there a right-angled triangle in that?
Yep.
Because if I go from here straight across, I now have a right-angled triangle. Okay? Where I know how high heights or the posts I've gone and so on. Okay? So I can find the right-angled triangle. A trapezium, not a trapezium, sorry, a parallelogram, which a few of you have seen. Is there a right-angled triangle?
No.
No? Not even if I draw a line straight down like that?
Yeah. Oh.
Right? I can do it like that. I can do it on the outside if I like. But actually, with a parallelogram, I have two right-angled triangles that are exactly the same.
So you have more.
You have four. Because you can cut it diagonally.
Yes, but if I cut it diagonally like that, which is what you were both saying, the problem with this process, as some of you were just finding on my other question, I don't necessarily know all this information. But yes, sometimes I get my rectangle and I can cut it in half and I've got that. Alright? But lots of shapes can end up having a right-angled triangle. So, for instance, I could draw an isosceles triangle. What's an isosceles triangle? Daniel?
Two of the sides are equal and one is not.
Yeah, so this side and this side, remember the notation for that?
And then the
Right.
bottom one is 2.
So let's say this is 10 and these two are 20 and 20. Could I get a right angle triangle?
Yep.
How?
Draw a line down.
If you go from the middle point all the way to the bottom,
Yeah. So if I go from this point down,
like straight down.
straight down, I'm looking at wonky, but you get the idea. And I've got two right angle triangles that are the same as each other. Okay? So all of these processes, remember the assessment that you are doing, alright, is all about right angled triangles. All of it. It's just whether it's got an angle in it or whether it's not got an angle in it. Okay? So, just remind me, if it's got an angle in the question, whether it's there in the question or you're being asked for it, what are we going to have to use? Trigonometry. So that trigonometry, when we say trigonometry, we mean SOHCAHTOA. So the sine of the angle, Michael, is? No? Sine of the angle can be found by doing opposite divided by cosine of the angle.
Opposite divided. Adjacent divided.
Adjacent divided by hypotenuse. And the final one, tangent of theta is opposite divided by the adjacent. Those give me the ratios of the sides. How do I find the angle? Yeah.
Inverse.
So I have to do the inverse of whatever ratio I've got. So if I know the opposite and the hypotenuse, I will have to do the inverse.
Cosine or sine.
Which one? Opposite hypotenuse? Inverse sine. If I know the adjacent and the opposite, I will be doing the inverse tan. If I know the adjacent and the hypotenuse, I will be doing the inverse
Cosine.
Now, when you do your test tomorrow, think of all these things you do know. And don't think it's something magical and new that you haven't studied. You've studied it all. So, yes. Okay, have a good lunch.